This is the first example from section 3.2, day 1. We're actually taking a step back from yesterday. We did day 2 of 2 different sections. But today is all about exponential growth and decay, and this is one example of how that starts out. Now, the exponential population model is essentially what we're working with throughout this whole lesson, and it's right here, as you can see. Population equals p sub 0, which is the initial population, and then 1 plus r to the t. R is the rate, and t is the time. So r is the rate each year, and then t is time in years, or whatever unit of time you'd like to use in a particular problem. It can change. It can be days, weeks, months, whatever you determine it to be, as long as it's consistent throughout the problem. So we're going to talk about when are we talking growth or decay in any of these types of problems. So the equation is growth when r is positive. Now you'll notice that in this one we have here, we've got 1.023. So this thing here is the whole thing inside the parentheses is called the growth factor. And so I'm just going to put that down here as 1.023. Now over here we have inside the parentheses what we call a decay factor. It's just whatever is on the inside there, and I want you to notice the difference about these two pieces. One of them is slightly above 1 and one is slightly below 1, and that's where r comes in. So with this formula we'll notice we have 1 plus r. So this becomes growth when r is positive. So in this case, what goes in on the parentheses, or what did go in on the parentheses, was 1 plus 0.023. That's how we got the 1.023 in this case. For the decay, and the decay factor, the decay rate, we have 1 minus, in this case, 0.028. Just working our way backwards on that, and that's how we get the 9.972. So if we're subtracting something, it's negative. If we're adding something as positive, that makes a lot of sense. But the rate is going to be 0.023 for that one, and the decay rate, since it's got decay there, that already indicates negative, so we can just call that 0.028. If you want to express this as a percent, like always, you just move the decimal over a couple of places. So this would be 2.3%, and this would be a decay rate of 2.8%.